All right, so since this doesn't group, we're gonna stop for a second and we're gonna think about what it means to be a factor. Because would you agree there are 3 factors to this problem? How do I know that? How do I know there's 3? Because it's x cubed. So I'm gonna end up with 3 factors. What does it mean when we say something is a factor of something? Like if I say 5 is a factor of 20, what does that mean?
You can multiply it to get to that number.
Okay, so in other words, 20 can be divided by 5. So if I say 6 is a factor of 11, you say no it's not, because 6 doesn't go into 11, right? Okay, so what I need to do is I need to find a number, a factor, that will divide into this thing evenly. So I'm just gonna start guessing, guys. I'm just gonna start guessing. So here we go. Have you ever divided before? I mean, I know you've divided. Have you ever divided polynomials before? Does synthetic division sound familiar to you? Synthetic division? All right. So guess a number. Daryl, guess a number.
3.
3. I'm going to do synthetic division with 3. Okay? So let's review that, how that works. This is Daryl's guess out here. Okay, that's his guess. So I like to put it in a little box. Now what are these numbers? Where do they come from? They're from the problem. So then I always take this number and drop it straight down. The first number comes straight down. Then I take 3 times 1 and write it here and add. Then I take 3 times 5, write it here and add. And then 3 times 10, write it here and add. Now Daryl had a great guess. It was a wonderful guess, but it didn't work. How do I know it didn't work? What does this tell me? What does that number right there stand for? Does anybody remember? That's the remainder. So remember, this is a division problem. This guy right here, this last number is the remainder. If something is going to be a factor, that means it's going to divide in evenly. So what was I hoping to get right here?
0.
A 0. I didn't. Okay. All right, let's guess again. Who has another guess?
2.
2? Okay, so I'm repeating. You're like, oh my gosh, Mrs. Ford, this could take forever. Oh. 2 times 1 is 2. Add. 2 times 4 is 8. Add. 2 times 3 is 6. Guess what? We found one. You guessed one. Okay. Now what? Well, the guess that you made is the number that you put on your x-axis. So when you guessed 2 and it divided in evenly, that means one of my dots is at 2. What does that mean about the factor? If the dot is at 2, and this number is always where you put your dot, always where you put your dot. So I put my dot at 2. What does that mean about my factor? X minus 2, yep. Yep, because remember it's the opposite. Now here's the really good news. You could keep guessing, but you don't have to. Because when you divided, this was the remainder. What was this part? What's that stand for? Anybody remember? In the division?
Isn't the first one x squared?
It is, Jared. So this is the quotient actually. If you divide this x cubed, this is what you're left with. And it's x squared plus 4x plus 3. And that is a quadratic. that you can either factor or use the quadratic formula on. So when you divided this out, your problem went from being a cubed down to being a squared. It always goes down by 1. Well, I think that factors, doesn't it? X plus 3 plus 1. So there are your other 2 factors, which means that your other 2 dots were where? -3 and -1. Remember, our goal was to sketch this. So now we've got our factors, now we've got our dots. Now it's an x cubed. Where do I start? X cubed,
Come on.
down here. Nothing bounces, it just goes right through.
Can I just really fast? I know you guys already went over this, but how do you know if it starts down or up the arrows?
Okay, we memorized that and behavior. So odd powers start down here.
Okay, that's
X cubed, x5, x7, all those start down there. Okay, now, we did it. Awesome. What's a potential issue with this? We got lucky when somebody said 2. I don't even know who it was. Who said 2? Daryl? Or I mean, Wyatt? Good. So you said 2. You got lucky because technically, could we still be guessing? There's a lot of numbers out there to guess, right? And this could take a very long time. Notice on the problem, you see that little PRR written there? This is not going to tell you exactly what numbers are going to work, but it's going to narrow down your possibilities. The possible rational roots, that's what PRR, I just get tired of writing out possible rational roots. But the possible rational roots are your pool that you guess from. So instead of having every number in the whole wide world to guess from, this narrows it down for you. And the possible rational roots are always, these are your guesses. This is where you're going to get your guesses from. It's always factors of the constant divided by factors of the leading coefficient. Now, what does that mean? In your polynomial, the constant term is the one with no variable. So what are the factors of 6? That's my constant. The factors of 6 are 6, 3, 2, and 1. Aren't those the numbers that go into 6? And we always must include plus or minus because we can pick positive numbers and negative numbers. When we were guessing, we only guessed positives, but we could have guessed negatives. What's the leading coefficient? That's the constant. This is the constant right here. What's the leading coefficient? This guy right here. And that's just 1. So worst case scenario, if you're guessing, there's only 8 numbers that you should guess. I know that's a lot, but it's better than infinity. So what are the 8 numbers? Plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. Those are your guesses. Now you guys, by yourselves, started with 3 and 2. They're in the list. But you would not ever try 7 or 5 or 10. You would never try any of those numbers. These are the only ones you should guess.
Is there like a situation where none of them work?
Yes, and that's a whole different problem. It won't happen to us.
Okay.
So for us, something's going to work. All right, let's try the next one then. You should always, when you look at your problem, you should always think about grouping first. Because grouping is easier than all this guessing stuff. Does your problem group? Look at it carefully. Letter B. Does it group? Do you think it groups? No, I don't think so, because certainly we could factor something out. But isn't this parentheses gonna have an 11 in it? I mean, there's no way they're gonna match. So that means I have to guess. Let's make our list. What are our PRRs?
Plus or minus 6, 3, 2, 1.
Factors of 6 over factors of 1. So plus or minus 6, 3, 2, and 1. There they are. There are your guesses. So pick one. What do you think? 3? 3's our guess, so we're gonna put 3 out here in the box. And then 1, -6, 11, and -6. So whatever number you're guessing, put it in the box. Then all of your coefficients here. And then bring this guy straight down to get started. All right, so here we go. 3 times 1 is 3. It works. 3 times -3. Yep, I think you did. You got a winner right off the bat. So that's awesome. What do we do if we don't get a 0 here? If we don't get a 0 here, then we have to pick another number. And we just keep guessing until we get one that divides it evenly. Okay, so now what do? Remember, we're graphing. So now we know that since that number divided in, I know that's a dot on my picture, so I'm going to put a 3. And I also know that because this is x cubed, I'm going to have 3 factors to my problem. And one of them is going to be what? X minus 3. Now I've got to get the other 2. You could keep guessing. Absolutely you could. But it's shorter and easier to look at this right here. When you divided that 3 in, it went evenly. And what does this represent? In the beginning, it was x cubed. What is this now?
X squared.
X squared. Always down 1. So this is where we're at now. Does that factor? I think it does. X minus 2 minus 1. And there are your other 2 factors. So here are my other, here are my other 2 dots. And now the only thing left to do is sketch. So here we go. Done. That's pretty impressive, you guys, that you can do that. Good work. We got incredibly lucky with a good first guess. Okay. All right, we got another one. What are our PRRs this time? Possible, that's the key word there, they're possible. These are the possibilities. So let's see, what are are they in this problem? Plus or minus what?
18.
2, 3, 6, 9, 18.
Yeah, so we have 18, 9, 6, 3, 2, and 1. The order you write those doesn't matter. And my promise to you is, you heard me promise, Mackenzie, somewhere in that list you're gonna get a winner.
Can we group
Big
this one?
What?
Can we group this one?
We can try it. We should always try. We should always think about grouping. So you wanna take out an x squared? And then you wanna take out a -3? Yeah, nothing wrong with trying to group. Grouping's always faster, always faster. But it doesn't always work.
On the test, will you have a section where we group and a section when we do
No.
this, or will it just all be?
Josh?
I thought on the PRRs, I thought you said that it would always be 6, 3, 2, 1.
Oh no, that's not what I said at all.
Oh.
I said it's always factors of this number over factors of this number.
If there,
If this number's a 6, then it's 6, 3, 2, 1.
but it says it's 8.
So it's all the factors of 18. All the factors of the constant over the factors of the leading coefficient. So technically this is only over 1 because there's a 1 there.
What do we do if there's a multiplier? Do we divide it by,
Mm-hmm.
so we multiply all the factors and then
No, you
divide?
don't multiply all the factors. This is a list. These aren't being multiplied. If that had been a 2, then you would have a 2 and a 1 down here. So then you would have things like 3 over 2
Oh.
as an option, and 1 over 2 as an option. That just opens up the possibility for fractional guesses.
Is that gonna be a situation?
Could be.
Wait, if it opens up the opportunity, does that mean that it's all divided, or does that mean it could be 18 or it could be 18 over 2?
It could be 18 over 1,
Oh,
or it could be 18 over 2. All those possibilities. Okay, so these are our guesses. Factors of 18 over factors of 1. Okay? So now we guess 1.
Do 2.
Try 2? So out here in the box, I put whatever my guess is. I put in the box. And then here are my coefficients. And this is gonna come straight down. And 2 times 1 is 2. Add. 2 times 6 is 12. Add. Oh my golly, you got another one. You guys, we're getting kind of spoiled here. Usually you don't guess right the first time, so just know it's okay if you don't guess right, just try again. Guess another one. That's why I left so much room in the notes, because usually we don't guess so well. Okay, so what does that mean? That means that one of my factors is what?
2, 0.
Well, one of my dots is gonna be at 2, 0. Perfect, which means one of my factors is x minus 2.
Yes.
There's 2 more. Now, where are the other 2 going to come from?
Down there.
Right here. And because the original problem was x cubed,
X squared.
this is gonna be x squared plus 6x plus 9. How does that factor?
X plus
3,
3.
x plus 3.
X plus 3.
So be 2 negative.
Okay, wait a second. Wait a second. That has some, I gotta think about what that means now for a second. That is x minus 2 times x plus 3 squared. So what does that mean for my picture? I'm gonna have a bounce here because of that. Now, it's still an x cubed, so it's still gonna start down here, right? But when it hits that, which is this, it's gonna bounce off, and that's what it's gonna look like. And that happened because we had a factor that was repeated. We have a squared factor. All right, let's take a minute. I have one more of these in the notes. See what you can do with this. And see, bless you. See if you can list your PRRs. See if you can make some guesses. And see if you can figure out what this thing looks like.
What doesn't this say?
What are your PRRs?
7 and 1. Oh, plus or minus.
Plus or minus 7 and 1, isn't that it? Wow. So those of you that like guessing 2, don't, right? What are the only numbers we're gonna guess? Plus or minus 7, plus or minus 1. 4 guesses. That's it. So start guessing. Tell me when you get one. 7 works?
It's so fast.
Yeah, you're right. 7 does work. You see how your PRRs can be a time saver here? Probably you wouldn't just start off with 7 as a guess, except that's our list, right? So yeah, PRRs are real time saver for you. They tell you what numbers you should be guessing. Okay, so I got a dot out here at 7. I have a factor that's x minus 7. Everybody catching up here? Are you okay? So then I'm going to come over here and look at this part. X squared minus 2x plus 1. How does that factor? X minus 1, which is x minus 1 squared. Now, I don't care if you rewrite it like this or not, but you've got to notice those match. And that means your curve's going to bounce there at 1. So it comes up from the bottom because it's a cube. It hits there and bounces back down and then back up. Is that all right with everybody? Okay. Wow. So now you can actually factor things that don't group. That's a pretty sophisticated trick. Good job. Good job. All right, now I have a little synthetic division practice in there just to make sure that we're good at it and to point out a couple of little issues. So I'm going to do synthetic division. What am I going to put out in the box?
The opposite of what's it?
So I'm going to put out in the box a
Positive 2.
+2. Now, before you dare get confused, remember a minute ago we had 7 in the box, that was our guess? And what did our factor become? X minus 7. So if I'm working backwards, if I'm dividing by x minus 7, that's going to be a 7. So that's why I have a 2 in the box. Now, as I'm writing down my coefficients, I notice that the cubed term is missing. Do you notice that? When you do synthetic division, this is one of the little things you have to be careful about. When you do synthetic division, every power has to be there. And if it's not, you have to fill in a 0. So it was x to the 4th and then x squared. So I had to fill in the 0. Everybody got that? Okay, we're ready. Here we go. 2 comes straight down. 2 times 2. Add. 2 times 4. Add. 2 times 11. Add. Oh, did I make a mistake?
No, I was just saying it's not working.
Oh, yeah. You're saying it's not a factor? Yeah, it's not a factor. So this question said just divide. But if the question had been, is this a factor? You would say no, because the remainder is 27. So what is our answer then? This was a division problem. So our answer is going to be 2x to the third. Yep, always one less. And this was x to the 4th. So 2x to the 3rd plus 4x to the 2nd plus 11x plus 13
Remainder from
plus 27 over x minus 2. You know how when you do division, you say 3 1/5, 1 over 5? Same thing here. We say 27 over x minus 2, whatever we divided by. So yep, it is not a factor. All right, go ahead and try B. And see if you can write your answer like this. Write your quotient out just like this when you're all done with the division. These numbers look right. Are those the numbers you got? So you said your answer was what? 3 x squared minus 10x plus 19
minus 15 over x plus 1.
Perfect. Beautiful. Everybody okay with that? Any question or problem with that? All right, one more. Here we go. Do that last one on this page. this. Does that look okay? Everybody good with that? 2-4 homework is due next Monday. Make note of that, the 2-4 homework is due next Monday. So maybe you can get that done and not have to worry about it before you go on vacation. All right, here we go, number 6. Is x minus 1 a factor of this? So we have this polynomial, and we're wondering if x minus 1 is a factor of it. How could we tell?
When we just plug in the positive one and then just solve it.
You mean divide?
Yeah.
What should happen? If it's a factor, what will happen when I do that division?
You should have a remainder.
I should have a remainder of 0, no remainder at all. Well, let's try it and see. What am I gonna put out here in the box? 1. So 1, -1, -4, 4. Make sure you're copying down all of your signs. Make sure you're putting in zeros if any of the powers are missing. All right, here we go. Is it a factor?
Yes.
Why? Because the remainder is 0. Great.
Can I put that as my reason?
That's your reason. The remainder is 0, or there is no remainder. These are factors when they divide in evenly. And this one left a remainder of 0. Perfect. Well, there's one more like that. Can you tackle it? What are you gonna say? If this is a test question, which it probably will be, what are you gonna say? Yes or no? No. Why not?
The remainder is 0.
What is the remainder?
I got 35.
35?
I might have done that.
Sounds like a little crazy.
I didn't get 35 for my remainder, but I could have made a mistake. Anybody get anything different?
I got negative 15.
I got negative.
Negative 15? I got negative 15. You got 13? Negative 15. Let's check our division. Did everybody, first of all, what'd you put in the box?
Negative 2.
Negative 2. Did everybody catch that you need a 0?
Yeah.
Remember, one of the quirks of synthetic division is that every power has to be there. So x to the 4th, x to the 3rd, x squared, x to the plane number. All that has to be there. So here we go. Yep, I got negative 15 again. So no, it's not a factor because the remainder turns out to be negative 15. Everybody good with that? Okay. I want to show you something because possible that you'll have a problem like this. Is x minus 1 a factor of 2x to the 77th minus 3x to the 4th plus 9? Something like that. Now, we've just done two questions just like this, and you did them easily. But you did them by division, right? Sure. But that's the way you should do it. Do you see a problem or a potential drawback with this problem, though? What would that problem be? That issue? Oh, there's gonna be a ton of zeros. You could do it, but you see how you'd have a 2, and then you'd have to have a whole bunch of zeros, and then you'd have your -3, and then you'd have more zeros. It would just be a very long problem. All right, so I want to show you something. And we use these last two problems that we just did. So here is this one. This was A, and we divided by 1, and the remainder came out to be 0. Go back up to the original problem, and let's, instead of doing dividing, let's put that number, that 1, let's put that number in for all of the x's. So 1 cubed is 1, 1 squared is 1, minus 4 plus 4. Now, total all that up. I just put a 1 here, and a 1 here, and a 1 here. And I'm gonna work out that math, and what's that gonna equal? That equals 0. Another way to find the remainder is just to plug the number in. So instead of actually doing the division, which will always work, you can always divide. But if the problem is too awkward to divide, you can just plug the number in. Let's do one more. I want to show you that this works. So this one was x to the 4th minus 3x squared plus 9x minus 1. So we divided by -2. So I'm going to plug -2 in here. Now I'm going to just do it in my head. You could do it on your calculator if you wanted. So -2, that's going to be 16 minus 12 minus 18 minus 1. Well, when I total all that up, 16 minus 12 is 4, minus 18 is -14, minus 1 is -15. So plugging the number in, whatever number you're dividing by, plugging it in will give you the remainder. So if I want to know if x minus 1 is a factor, what number would I put out here to divide?
1.
A 1. So instead of dividing, I'm going to plug 1 in. So 2 times 1 minus 3 times 1 plus 9. This gives me my remainder, which is 8. So without dividing, I know my remainder is 8. Is it a factor? No, the remainder is 8. So again, you can always divide. To find a remainder, you can always divide. It's just sometimes it's too big and awkward. All right, one more problem, and I got something I need to do. So one more, here we go. Given 1 0 for the following, find the others. So x equals 1 is a 0 of this polynomial. Can anybody tell me what that means? What's it mean to be a 0? Where do I see zeros, or where do I put zeros? On the x-axis, that's exactly right. So whatever this thing is, I know it has a 0 at 1. What's a factor then? If that's a 0, then one of the factors is x minus 1. And if it's a factor, doesn't that mean it should divide in and give me a remainder of 0? So what if I did my division? There's my dot, there's my number. I knew that would happen. It was a 0, it was a factor, I knew it would divide in. Where are my other zeros gonna come from?
Oh, it's on bottom.
What's left? Aren't you gonna come from right here? That's 3x squared plus 7x plus 2. Aren't the other zeros gonna come from right there? They sure are. 3x and x and 2 and 1. I think that works. By the way, I can't factor because there's a 3 on there. And that's too hard for me. What could I do with this problem? Quadratic formula, sure. And what are my other 2 roots? It says find the other 2 zeros, yeah. So the other 2 zeros would be -2 and -1/3. You set this equal to 0. You're gonna get -1/3. So given 1 0, they told you 1 was a 0. We divided it out, and this part right here left me with the others. Okay? Alright, I gotta stop there because now I need one brave volunteer to come to the board. Quickly, quickly, quickly. One. Quickly. Rush up. Who's doing it? Jared, thank you. All right. I need you to use synthetic division, Jared. We've got a problem right there. The fate of the class rests on your shoulders.